Hello, Bridge. How are you doing? Hopefully well. This is week 3. It's the second assignment, and I have a bridge of the day. Check it out. Any guesses? Maybe it's one you're familiar with. It is in the Pacific Northwest. It is the Bridge of the Gods in Cascade Locks, Oregon. Connects the Washington and Oregon side together. We are still looking at logarithms, and we're going to be focusing again on the change of base formula to make sure that feels very comfortable before we start using them to solve exponential equations. So I'm going to go over a couple examples, and then I'm going to go over what I'm looking for the assignment for this week. So the change of base formula, let's review it real quick. I'm going to keep that picture there so we can keep looking at it for reference. Basically, if you have a logarithm, right, and we have a log, maybe it has a base of a base of b, and you have an a there, right? In the last video, I used different letters. Again, it's the same thing. We're just got to keep consistent with where these letters are going, right? So let's just say that I have a base of b, and I have this answer a, and again, this logarithm expression is really saying what power do I need to raise b to in order to get a, all right? And if we want to evaluate this down, because maybe it's a logarithm that isn't as nice as just saying, oh, the answer is 2, or oh, the answer is 4, right? Maybe it's some kind of crazy decimal, like 3.0123, whatever. We have to figure out how exactly to get that decimal. What we're going to do is use the change of base formula and pick a new base, and in the picture, you see that we have a base of x, okay? So in here, in this case, we're just picking a new base. So I'm going to say x, pick a new base, and since our calculators work really well with base 10, and we want to use our calculators to make it easy, we're really always going to choose a base of 10. So you're pretty much always going to choose a base of 10. So I'm going to say log base b of a is equal to, what you do is you take log base 10, or base x if you pick a new base, but again, we're usually just going to pick a base of 10. So log base 10 of a, okay, of that number right here, divided by log base 10 of b, of our original base from the original logarithm. And then that's something that you type into your calculator. Since you have calculators that work with base 10, all you really do is use the log button, so you should be typing in log a divided by log b, and it's going to estimate an answer for you, okay? Again, this is the same kind of stuff that we did, so I want you to evaluate this logarithm using the change of base formula. Okay, so we're looking at the first example where we're going to use the change of base formula to evaluate what this logarithm is. Again, this thing is saying what power do I need to raise 4 to in order to get 56. So I'm going to use the change of base formula. I'm going to pick a new base of 10, so I'm going to take log base 10 of 56. Okay, so that's that number here. Divided by log base 10 of my original base 4, log base 10 of 4, and I typed that into my calculator, log base 10 of 56 divided by log base 10 of 4, and I estimated about 2.90367. It just kind of keeps going, ... So to check my answer, because what this is saying is that 4 raised to the power of 2.9036, whatever, should be equal to 56. So on my calculator real quick, I'm going to raise 4 to check my answer. 4 to the power of 2.9036, ... whatever that, it just keeps going on. So 4 raised to that power, and it does indeed give me 56. Or if you rounded this number here, you're going to get like 55.9999, which is going to round up to 56. Okay, so that logarithm right there evaluates down to that. We used our change of base formula. Okay, here again, this is just a really quick one. I'm just making sure we all remember that if there is no base that is written here, we're going to assume that it is a common log, and common logs always have a base of 10. So here I'm going to say log base 10 of 10,000 equals what? And since our calculators work really well with log base 10, I don't even have to use the change of base formula, right? This log already has a base of 10. So in my calculator, I'm just going to plug in log of 10,000, and I'm going to get 4. And that just makes sense, right? Because I've got like 4 zeros on the back side here, so it's really doing 10 times 10 times 10 times 10, and that will get you 10,000. Okay, so common logs with base of 10, you could just use your calculator right away, but if you have something that doesn't have a nice base, you're probably going to need to use the change of base formula. This right here is going to be your assignment. There's a couple questions that are very, very similar to this in the same format, and I'm going to take you through how exactly to do this real quick. I'm going to get rid of this change of base photo. Okay, so what I'm going to have you do is I'm going to give you a log. I'm going to ask you to make a guess. It does not have to be perfect. It doesn't even have to be close. And then I want you to find the true value, and then I want to figure out what the error is. Okay, so I'm going to pick red again. So I have this log base 2 of 16 equals what? I'm going to make a guess. Okay, my guess is 4 because I already have it memorized. I know 2 to the 4th power is 16, so my guess is 4. And to use the change of base formula, I'm going to pick a new base of 10 and say, okay, log base 10 of 16 divided by log base 10 of 2, that original base. If you plug that into your calculator, it is going to give you 4. And the error is your true guess, or your true value minus your guess, right? To see how close you were. And so here my error is 4 minus 4, and that equals 0. I was spot on, right? There's no margin of error there. Okay, there's probably going to be a margin of error with this next one. Log base 2 of 14. Now I know I'm definitely going to have to use the change of base formula because this isn't something that I have memorized. I know 2 to the power of 3 is 8. 2 cubed is 8. I know 2 to the 4th power is 16. That's what we just did, right? But 14 is in between 8 and 16. Okay, so this 2 cubed, which I know is equal to 8, right? And then there's 2 to some sort of power, which has to be equal to 14. And then there's 2 to the 4th power, which equals 16. Okay, so my guess, all right, that's why I want you to make this guess, this estimation. I know that it should be somewhere between 3 and somewhere between 4 because 14 itself is between 8 and 16. So I'm going to say 3.9. It's pretty close to 16, right? Or it's pretty close to an exponent of 4, but it's not exactly 16. But it's not exactly 4. Anyway, I'm going to make this guess of, I think 2 raised to the power of 3.9 is going to give me 14. And then I'm going to use my change of base formula to see how close I actually was. So log base 10 of 14 divided by log base 10 of 2. Again, I typed that into my calculator as log 14 divided by log 2. And you do get a value of 3.80735. And then you can just subtract those two numbers. So I'm going to subtract 3.9 and 3.87, whatever, yada, yada, yada. 3.9 minus 3.80735. And that gets me a margin of error of 0.09265. So I was pretty close. And that was a good way to estimate and to guess kind of the ballpark of what your logarithm might be. Let's do the next one real quick. Log base 7 of 40. Okay, I'm going to think about this. I know 7 to the 1st power is just 7. I know 7 squared is 49. And 40 lies between 7 and 49. So I know that my value that I have to raise 7 to, it has to be between 1 and 2, right? So 7 raised to some x value, that's kind of what we're trying to solve for. 7 raised to some power equals 40, and I know that that power has to be somewhere between 1 and 2. And I'm going to say it's probably going to be closer to 2 since 40 is closer to 49 than it is 7. So I'm going to guess 1.7. That's my guess. Okay, now we can actually find the true value. I'm going to say, okay, log base 10 of 40 divided by log base 10 of 7. And that gets you a value of 1.895709. So that was pretty close as well. But now I can find my error and just, subtract those two numbers. I'm going to keep moving for time's sake. I think you can subtract two numbers. Log base 10 of 300. Okay. Again, if I have to kind of make an educated guess, I'm going to use some things that I know. I know that 10 to the first power is just 10. 10 to the second power is 100. And 10 to the third power is 1,000. Oops, one more zero. It's 1,000. And 300 lies between 100 and 1,000, right? So the exponent that I would have to raise 10 to in order to get 30, this value of x, it has to be somewhere between 2 and somewhere between 3. Again, because 300 lies between 100 and 1,000. So I'm just going to make a guess. You know what? I'm going to say 1.2. Or I'm sorry, it has to be between 2 and 3. See, that was not a good guess. I'm going to say 2.3. Why not? Why not? Okay, and then evaluating this logarithm, I don't even have to choose. I don't even have to use the change of base formula because this is already a base 10 logarithm. So I can just plug into my calculator log of 300 and see what that gives me. I don't even have to use the change of base formula since it is already a base of 10. So I'm going to say log of 300 and plugging that into your calculator, I do get 2.47712. Okay, so I think that using these, being able to estimate this and make an educated guess gets you really close to the number. So there are going to be a couple examples on your homework that I'm going to ask you to make a guess. Hopefully it's an educated guess. You shouldn't be making a guess of 0 if the number isn't 1. You know what I mean? Try and get pretty close. Do your best to show your work. Use the change of base formula. Show me what you got. You're probably going to have to round some decimals. Okay? All right. Have a great day. Bye, Rockets. Go team.